Hello everyone, welcome back to this data science series. In this lecture, we are going to cover regression modeling. So far in this series, we have covered um, classification task and clustering task. Now, two tasks are more remaining, which is association task and estimation task. In this lecture, we are gonna cover association task. So let's get started. Introduction to regression modeling. So, what exactly regression modeling is? It is association or it is describing the relationship between a numeric variable or a continuous target. So, we can have numeric predictors which can be either one or more than one. Then we'll explore the relationships of these numeric predictors with the continuous target or the variables on which they can influence. Then we can make informed decisions and we can have wide applications. Assumptions of regression modeling: linearity, normality, independence, and homoscedasticity. Linearity is the relationship between independent variables which should be linear. Normality is the error terms that should be followed in normal distribution. Independence is the error term should be independent to each other, and the variance of the error term should be constant across all the values of the independent variables. Now, simple linear regression. In simple linear regression, we have just one numeric predictor, single numeric predictor, and we associate the relationship between this single numeric predictor to the continuous target using a straight line, and it have one independent variable as I said that, and we have a linear equation in a straight line, and straight line is represented by y equals to mx plus c. Then we have a visual representation which is represented by a line of best fit on scatter plot, and then we can calculate the coefficients m and c, which are slopes and intercepts. Then we have multiple linear regression. In multiple linear regression, we have numeric predictors more than one, which is p is greater than 1 and just one continuous target. And we establish the relationship between these predictors, which are more than 1, to the continuous target using a p-dimensional plane or a hyperplane. So there are multiple predictors, then combined effect, because each independent variable's effect is considered, and then it is summated, and then the accuracy is increased because we have influence of several predictor variables, but it results in complex analysis. Now let's have a look on what we were talking about in the mathematical term. So here there are two key components of regression modeling, which is dependent variable and independent variables. Dependent variable is also known as response variable, and independent variable is also known as predictors or features. So why here is a dependent variable? Because it is depending on the values, where beta 0 is intercept, which is the value of y if all the x1 x2 all the predictors are 0. E is the error, and beta 1 beta 2 beta up to beta p are the values, and x1 x2 to xp are the predictors, which are independent variables. So let's move on to the next slide, which is model evaluation. Like we have established multiple regression or a simple regression, but how can we evaluate this model? It can be by R squared method, a root mean squared error method, a residual analysis method, or a hypothesis testing. But how is this stepwise regression done? First, we select the variable, then we use the iterative approach, like iteration is done, and then we have model optimization, then statistical criteria. Now, before that, before moving to the conclusion, let's have a look on the code of regression modeling, which is this. Here we have imported the packages, and then we have taken the example data. Then we have features and target. Then we are splitting the data set into training and test data sets. We are creating a linear regression model here. So we have just one predictor. This is x only, and this y is a dependent variable and x is independent variable. Now we are predicting on the test set and then evaluating our model. Now let's have a look on the output. Yes, so these are the measures of our evaluation matrices, which shows us that our code has worked and executed successfully. And this is stepwise regression using Python, or we can say multiple regression. Here we have used predictors which are more than one. See, x1, x2, x3. These are three predictors which we have used. Multiple predictors, and this is y continuous target. We have defined the independent and dependent variables, x1, x2, x3 being provided independent variables and y being provided independent variables. Then we have adding the constant and then models. Then backward elimination process is being used. After that, this code is being run, and this is the output of our code. So this is kind of complicated, but it is more accurate than simple regression. Let's get back to our presentation, and here it is. What is the conclusion? So first we can think of a regression model as a powerful tool, and we have to know that there are predictors and categorical data sets, independent variables and dependent variables, and then we have to evaluate the model. We can further explore it like logistic regression and time series regression. But for now, this is it for this video, and we will learn about dimension reduction in the next lecture. Till then, stay tuned. Thank you for watching this video.